Number 56. So continuing on with the solving of systems. In this system, we have lined up in a nice vertical fashion like terms x squared and y squared and constant. So I'm thinking the addition method would be good here. We want to try to make both of these either the same number here for the x's or the same number there for the y's. And I can't directly just multiply one equation through by something, but if I manipulate both equations, like right here to make 2 and 3 be the same number, the LCD is really what's in my head. I'm trying to think, I want to make them both 6's. So I could either make both of these 6's, or for 4 and 3, what's that LCD there? And it's going to be 12. Make both of those 12's. I'm going to go for this one just because the signs are already opposite. I kind of like that, but you do it either way and it works. So to make this a 12, I've got to times the top equation by 3, and to make this one a 12, I have to times by 4. And that's okay because you just have to times through, you know, horizontally the same equation by a number, okay? And this one can be completely a different number. That's okay. They're different. They're independent equations. So the first equation by 3, distribute that. And the second equation is by 4. And now we've done it. We've got, so that when we add, these will cancel out. And that's our goal with the addition method, something has to cancel. So now adding down, I'll get 17x squared. This will cancel as per our design, and then adding this way, like so. It is solvable. We can divide by the 17. I need that calculator this time. 25. Okay, and that's convenient because 25 is a perfect square. It wouldn't have to be, but it makes it nice. So when I square root each side, I'll get a nice number. So one thing I would remind you of here that would be easy to forget is when you square root each side, you have to say plus minus. There's 2 answers to that. So make note of that if that's something we haven't done that in a little while. Square rooting makes a plus and minus solution. So we got 2 answers for x, positive 5 and negative 5. Now we need to find the counterparts. We always need a point, an x and a y. So both of these are x's. So one at a time, I'm going to take positive 5, plug it in for either this x, or I wouldn't probably do it in these just because they're bigger. It can be any equation. So I'm just going to take the first one. And again, I'm plugging in x is positive 5, plugging that in for x to figure out what y is. So it looks like that. Remember to square before timesing, so 25 times 3, or just do it on your calculator, right? Then take the 75 over. Why don't y'all help me on that one too? 39 minus 75. Negative 36. Then I can divide both sides by negative 4. And so that's negative over negative, so it's positive 9. So here we are again in this square root situation. When you square root, you say plus minus. So plus minus 3, again, it's just handy that it was a nice number, but it wouldn't have to be. So what just happened is I plugged in a positive 5, and I got 2 y values, 3, and also positive 5 gave me negative 3. And have yet to plug in the negative 5. But what's going to happen when I plug in negative 5 is it's exactly the same thing, because a negative squared, and it's a negative plugged in for a variable, so the negative is squared, comes out to be exactly the same steps. So when you plug in negative 5, you also get 3 and negative 3, making a total of 4 touching points or intersection points here. If we were to draw these 2 figures, and this isn't something we actually covered, Chapter 6 is optional. We just touched on that they're conic sections, but we didn't actually cover, and you're not responsible for it. But just so you know, if you were to graph these, what we've got here is an ellipse, and this with the minus is a hyperbola. So we've got a figure that could cross in 4 places. 1, 2, 3, 4. And if we actually took time to graph those, we could see that there's intersecting 4 places. So expect 4 answers potential on some of these. All right. Let's go and get 57 for the reading problem. And then we still got to go back and hit the ones I've skipped. Just a few more. Okay, number 57, if you'll read that with me. There's 2 formulas that you would need to be familiar with in this problem to work it. It's about a rectangle, to remind you. It always helps me to draw pictures, so I'll just sketch one in there. We've got some rectangular plot, and it tells us that the area, it tells us what the area is, and it tells us what the perimeter is, and it says figure out length and width. So we're given the area, so you do need to know area of a rectangle is its length times width, so multiplying the 2 dimensions tells you the area inside, and perimeter is the distance around a figure, is 2 of the lengths plus 2 of the widths would give distance around. So in this problem, it tells you area is 126 square yards, it's in yards, and perimeter is 46 yards. So we're able to sub it out and get 2 equations like we've been doing in the other problems. So this problem really couldn't use the addition method in because LW is actually a term. With L, that's not like terms, it's not like terms there, so addition would kind of be out for this one. So definitely going to need substitution method. One thing I would recommend, and this is true for all equations, if you see something that reduces, we might as well do that. So all of these have 2's in it. Divisible by 2 makes that a 23, just a 1L and a 1W. I'm going to call that equation 1 and this equation 2. It's just a nicer version of that. That's optional, but I think it helps. So now looking at these 2, I'm feeling like the substitution method would be good. Maybe use this 1L as the substituting method. So to solve for L, I throw the W across. We could have done that vice versa as well, and it works out. But this is what I'll choose to do, is solve for this 1L. So now that I have L solved for, I take this and sub it in for L in the other equation. So I put it in the equation right there, subbing it out, they're interchangeable, and rewrite it as 126 equals, instead of L, 23 minus W times W. And now I'm to an equation that can be solved. Again, you just can't solve an equation that has 2 unknowns. If there's just one equation with 2 unknowns, it's got multiple solutions. That's what we do when we graph, is all the multiple solutions. But if we can create it into just one variable, then you can solve it. So here we go. I'm going to distribute, and the W seems on the wrong side. If that's bugging you, put it in front of it, because it doesn't matter. It's still just a multiplier that distributes. So we got 23W, and W and minus W, it's minus W squared. So that is a quadratic. The quadratics are back here. So I'm going to bring everything over to the left side. You can go left or right, but I'm going to choose the left side because I want my W term to be positive. That doesn't have to be, but it's easier for me to visualize it and work it. So I'm bringing these 2 over to this side, and the 126 was already on the left. So now I've got it in standard form. From there you can factor or formula it. I know it's WW. I know it's a minus times a minus to get a positive last term, but still get that negative in the middle. And then we're punching on our calculator, trying to see what multiplies to be 126. I have no idea, but you might look at some of the answer choices and get some ideas. Looks like 14 times 9 multiplies to be 126. And then when I FOIL it, that's minus 14W minus 9W, which is the right middle term, minus 23W. So that works. So you get it factored. Then set each factor equal to 0. Gives us 2 solutions of 14 and 9. So we have 2 answers. Then we need to go find its counterpart, its length. So just like all the other ones, we can go back to any form of the equation. And I think I like this one right here. L equals 23 minus W. That's the good thing about the substitution method. You usually have an easier equation to plug into. So I'm going to start with 14. L will be 23 minus 14, which is 9. When W is 14, the length is 9. So I'm going to put those, let's see, maybe it doesn't really say what order. We're going to talk about that in a minute. But I'm going to assume L is first and W is second. Then I'm going to put in W is 9. Do the whole thing again. Plugging in W is 9. It'll be 23 minus 9, which is 14. So the other rectangle would be a 14 by 9. So they're really the same rectangle. It's a 14 by 9, whether you do it this way and make this the long side, 14 by 9, or you turn your rectangular plate